All right, so the first section tonight, we're going to refresh ourselves on multiplying polynomials together. So a really easy lesson in this particular section. So we're multiplying out 3x. For the first example there, we're multiplying out 3x times 4x plus 3. So when I multiply, I'm distributing. So it's numbers times numbers. So 3 times 4 would be 12. And what's x times x? X squared. Yeah, add the exponents on your letters. And then 3x times 3 would be plus 9x. And you've multiplied that out. Notice that we wrote our answer in descending order, starting with the highest power of x. You want to do that. You want to have your highest power of whatever variable you have, put it in the front, and go down from there. Typically, it's going to be there already because what they give you is in descending order, but it's not always. So sometimes you need to pay attention to that. Over there to example B, we got a little higher exponent there with the negative 5x times negative 2x minus 8. So a lot of negatives in this problem. But when we distribute, you want to make sure you distribute that sign with it. So that's a negative 5 times a negative 2, which is going to give us a positive 10. And then what's x squared times x? X cubed or x to the third power, whichever way you want to say it. And then the last piece there, negative 5x squared times the negative 8 would be positive 40. Excuse me, and the x squared just carries over. And that's in order from biggest to smallest already. Okay. All right, so that's just regular old distributive property. We've done that a bunch of times. Now let's get into double distributive property is what I like to call this. You may have heard this in high school called the FOIL method, first, outer, inner, last. It's the same thing as double distributive property. It really is exactly the same. What I do is I distribute the x first. So x times x, that's going to be x squared. And then x times 4, that's going to be plus 4x. And then I'm going to distribute the plus 3. Plus 3 times x would be plus 3x. Positive 3 times 4 would be positive 12. Once I've done that, and that's the same thing as FOIL method. First times first, that's x times x. Outer times outer, that's x times 4. Inner times inner, 3 times x. And then last times last is 3 times 4. So that's the same thing as FOIL method. So if you Google FOIL method or multiplying that together, it's that you may see somebody that calls it FOIL. I don't call it that because it only works with this size. It doesn't work with bigger ones. Now, last thing you got to do on this one is put together the like terms. You got a couple of them in the middle there that go together. So that's going to be 7x plus 12. And that is in order from biggest x to smallest x, as far as exponents go. Doesn't matter what number's in front, it's the exponents. Okay. What's our first term on example D? And then, so x times the 2x would be 2x squared. Then what goes next? Which is 5x. And then we're going to distribute the negative 7, negative 14x. And then last, negative 35. And then we put the like terms together in the middle there. So we got that positive 5x and a negative 14x that go together. So that's going to be 2x squared minus 9x minus 35. You've got it worked out. Really easy to do. Nothing just extraneous, no really tough stuff here. No strenuous work here. Knowing your multiplication tables makes you faster at it. Doesn't necessarily make you better at it, but it makes you faster at it. So let's do one that looks like this. 2x plus 7 times 2x minus 7. Is that any different than example C and D? Not really. 2x times 2x, then times the negative 7, so that'd be negative 14x. Then we multiply by the positive 7. It's a positive 14x and a negative 49. What happens in the middle there? They cancel out. That's nice. Just gives you 4x squared minus 49. What those factors are called is called a difference of squares. That'll come up in the next section when we talk about factoring. So in this section, we're multiplying together. In the next section, we're going to unmultiply. We'll break them apart. So when the factors look exactly the same, but one's a plus and one's a minus, that's called a difference of squares. So that'll come up again in a little bit, and we'll address it then. Okay. All right, let's go a little bit bigger. Let's go x plus 5 times x squared plus 6x minus 3. So a little bit bigger problem. My 5 look a little bit better. So on this one, it's not FOIL because you have a bigger piece there on the end. You got that x squared plus 6x minus 3. So you got a little bit bigger piece there. But it is double distributed property. So that's why I call it that, because it works on this too. So the first thing you're going to distribute is the x. So x times x squared, x cubed, plus 6x squared minus 3x. Then I'm going to distribute the 5. So that's a plus 5x squared. That's a plus 30x. That's a minus 15. So this one I've got a little bit more to do because I've got more like terms. Got an extra set of them. So I've got the 6x squared going together with the positive 5x squared. So that's going to be x cubed plus what? 11x squared. And then, so I'm done with those two. The next set is the negative 3x and the positive 30x, which together would be not negative, but positive 27x. Which one's bigger, the positive 30 or the negative 3? The positive 30. So that's why it's going to keep the sign of the 27. The 27 is going to be positive because 30 is bigger. And then last, we just got the minus 15, just tacking it on to the end down there. And there we've multiplied out a binomial times a trinomial is what that is. 2 terms times 3 terms. Not incredibly difficult, just a little bit longer. A lot of places, that was how many operations? 1, 2, 3, 4, 5, 6, 7, 8 operations to get that done. So there's a lot of places that you could make mistakes. So just be careful. Take your time. Do one piece at a time, as Johnny Cash said. One piece at a time. Didn't cost me a dime. All right, here's a fun little math problem. What does it mean to square x plus 5?
X plus 5 times x plus 5.
Yeah, rewrite it twice. So I'm going to do x plus 5 times x plus 5. And then I'm doing the same thing that I did on example C, D, and E. Doing all the same stuff there. So x times x is x squared plus 5x plus another 5x plus 25. And then combine your like terms to finish it up. There is a shortcut, like a little formula that you can use for that. I don't think it's any faster, so I don't ever do it. I mean, the shortcut is to double the middle. Like you got the x, you got to square it, you got to square the 5 to get the 25. And then in the middle, it's x times 5, but double it. By the time I remember all of that stuff, I could have just done that. So I don't ever do that shortcut. I just multiply it out. The shortcut doesn't really help me. Okay. Next one. Let's do a little bit tougher one. 2x minus 3 squared. So this is a little bit harder because it's got a coefficient there in the front. But what does it mean to square that? Yeah, 2x minus 3 twice, and just multiply it out. 4x squared minus 6x minus 6x plus 9. Be careful on your signs. Negative times a negative is that positive 9 down there. Most common mistake is folks forget to change that to a positive. And then combine your like terms. 4x squared minus 12x plus 9. It's quick and easy. Nothing too strenuous about that. That's pretty good. X plus 3, x minus 3. Now this does have a shortcut that I do use. Because when I look at those two factors, or those two things I'm multiplying together, they're exactly the same, one's plus and one's a minus. We saw this earlier. What happened to the middle part? They cancel out. So my shortcut on this is that I just multiply x times x and 3 times negative 3. And then the middle part's going to go away anyway. So it's going to be x squared minus 9. If you didn't do that shortcut and you actually multiplied this out, it isn't that much longer. It's really just all that happens is that. Those cancel each other out. It really doesn't shorten it up that much. But just seeing that and recognizing it as a difference of squares can help you get through things a little bit quicker, recognize some patterns that are happening. That's supposed to be an X there. I don't know what happened. There we go. 5x plus 9, 5x minus 9. Is that a difference of squares?
Yes.
Yeah. So if I just multiply 5x times 5x, and then the 9 times 9, and put a minus sign in the middle, that's the shortcut on a difference of squares. If you don't remember that shortcut, or you get into doing the problems and you just aren't even thinking about that, and you just did 25x squared minus 45x plus 45x minus 81, you're still going to get the same answer because those 45x's are going to go away. It's not going to change it. It's just sometimes having a little shortcut can help you. Okay. Let's do one more in this section. X plus 2 to the third power. What's that mean? Yeah, write it down 3 times and multiply it together. Okay. Now, it doesn't matter which 2 of them you multiply together first. It's just almost impossible to multiply all 3 of them together at once. I usually will put these 2 together and leave that x plus 2 on the left just hanging there for a second. And I'm going to multiply those 2 together first. It doesn't matter which 2. If you did the first 2 and then had the other one on the end, I just like having my distributive property in the front. So if I multiply these 2 together, that's going to be x times x is x squared plus 2x plus another 2x, then plus 4. I've still got this x plus 2 that I haven't used yet in the front. So I'm going to simplify that long one there and make it x squared plus 4x plus 4. And then I'm going to distribute my x plus 2 to that. It's x cubed, 4x squared, 4x, then 2x squared plus 8x plus 8. So I just distributed the x to all 3 of those pieces, distributed the 2 to all 3 of those pieces. And then I'm just going to start combining like terms. I got the x cubed, I got x squared and x squared, that'd be 6x squared. I got the 4x and the 8x, that'd be 12x plus 8. Not really a shortcut to that at all, other than just multiplying it out. Write it out, multiply it out. One piece at a time. That's the easiest way to do that. Okay. Questions about multiplying polynomials together. Really, probably the easiest section we got tonight. Well, maybe second easiest. The last one's probably the easiest. All right. Let's jump over into R4, which is unmultiplying, or factoring is what we call it in math class. But it's unmultiplying. And so when you're factoring, I have a set of rules that help with factoring. So the rules of factoring. If you'll follow these rules, it will make your life in factoring world lots easier. Okay? The first rule is make sure your equation or your polynomial that you're trying to factor is in descending order. That means, like x cubed plus 3x squared minus 5x minus 15. That's descending order. Okay? Make sure it's in that order. If it's not in that order, that doesn't mean you can't factor it. It's just going to be harder. So if you put it in descending order, it gets a lot easier. It just organizes things to make your life a lot better. Okay, so anytime we can do that, we want to make anything in math. If we can make it easier, we want to make it easier. Okay. Now, once you have it in descending order, the next thing you want to do is you want to look for a greatest common factor. We abbreviate that GCF. Okay, that is the first thing you always look for in a problem to factor it, is a GCF. That doesn't mean every problem has one, but that's always what you look for first, is the greatest common factor. You may have heard it called the greatest common divisor. It's the same thing. Okay, so if you Google factoring and you see somebody calling it a GCD instead of GCF, it's the same thing. Okay, greatest common factor, greatest common divisor, they are the same thing. Okay, after you've pulled out the greatest common divisor, or you've discovered that there is not one, the next thing that you do is you count terms. Okay, based on how many terms there are in the problem tells you what method to use for factoring. Okay, if there are 4 terms, we're going to use a method called grouping. If there are 3 terms, we're going to use what I call the X method. If you had Ms. Isbell at McNair Central, she doesn't use the X, she uses a table, like a T table. I use an X. Just my way of doing things. But you'll see this, you'll remember it, and you'll think, oh yeah, I remember that. If there are 2 terms, it can either be a difference of squares, it can be a sum of cubes, or it could be a difference of cubes. So how do you recognize those? Well, squares. What's exponent is squares? 2. Okay, so it's got an exponent of 2 and a minus sign. Okay, difference in math is minus subtraction. So difference of squares is the subtraction of 2 things that are squared. So we're looking for an exponent of a 2. Now, what is the exponent for cubes?
3.
3. So exponent, and then it's a plus sign in the middle. It's only two terms. You got an x to the third power or whatever letter they're using. And then you've got cubic numbers, things that are third power. Okay. Difference of cubes is also an exponent of 3, but it's a minus sign in there. We'll talk about those. There's a pattern that we can use to factor those as we go through here. So a lot of factoring practice here. That's probably the most difficult part of tonight is the factoring. So there's a lot of examples. We don't get quite through the whole alphabet, but we get close on this one. So want to do a lot of examples of this because it is probably the thing that my students at the high school struggle with the most. Like if they have trouble in Algebra 2, it's because they struggle with factoring. If you struggle in college algebra, it's because you struggle with factoring. So I'm going to do a bunch of examples of this and kind of help you learn it. If you didn't learn it in high school, you can learn it tonight and be very good at it before you leave here tonight. Okay, so the instructions are factor the polynomial. So if we're going to factor the polynomial, here's our first one. We'll start easy. 5x plus 10. So first thing that I want to look for is descending order. So highest power of x first and then go down from there. There ain't much to count on here because there's only that two pieces there. I got x in the front and no x's in the back. I'm in descending order. I'm good to go. So the next thing that I look for in my rules of factoring was a greatest common factor. So I look for something that goes into 5x that also goes into 10. 5 goes into both of those. So I factor out a 5. Well, what times 5 gives me 5x? That's where that x comes back. And then 2 for the 10. Okay? Then look at what's in the parentheses and see if you could factor it anymore. You can on this one. This is all that this one does. It's GCF. Okay? There's two terms. There's not an exponent, so I know there's nothing else I can do. So I'm done with that. That is in factored form. Okay? Good news. Let's go to this one. 6x squared plus 8x. So this one, got to think a little bit more about descending order. So we got an x squared in the front, then a plain x. That's the biggest one, then the smaller one. So that's in order. Then I always look for the GCF first, the greatest common factor first. So what goes into both of those? 2. And then they both also have an x. The first one has 2 x's. The second one only has 1. So how many do they have in common? Not 3. 1 in common. So if the first guy has 2 and the second guy has 1, there's only 1 that they have that's the same. So the common factor there is 2x. Now what times 2x would get me 6x squared? 3 and an x. And then what times 2x would get me 8x? Plus 4. I don't need another x because that 2 out here, because what you got to think about is if I redistributed this 2x, do I get back what I started with? 2x times 3x is 6x squared. 2x times 4 is going to be the 8x. So I don't need another x on the 4. And then that's only 2 terms. It doesn't have an exponent, so I know it can't be any of my 2-term things. So I'm done. That's all I can do on that one. So just getting a GCF out of these first few. Got to get the habit of that. If we can do GCF, we can do the rest of it. GCF is the muscle of factoring. It does everything else. So it's a very, very important part. All right, let's do this one. Negative 15x squared plus 10x cubed. What do we notice about this one? It's not in order. So let's put it in the right order. 10x cubed minus 15x squared. It doesn't mean I can't factor it when it's in the wrong order. It just means it's a lot easier when it's in the right order to get it factored correctly. Okay, so first thing I look for is the GCF. 5 and an x squared. Good job. First one had 3 x's, second one had 2 x's, so they got 2 that match up. What's left in the parentheses? 2x minus 3. Good job. All right. Let's do another one. Let's do 7x squared plus 9x to the 5th power. Ooh, big one. So is it in the right order? No, definitely not in the right order. So I'm going to rewrite it as 9x to the 5th plus 7x to the 2nd. So it's a plus because that was a positive 7x squared. And that 9x to the 5th was positive, so it's just regular 9x to the 5th. So now, GCF of that. X squared is, because the first one has 5 x's, the second one has 2, so they got 2 that match up. Now, number-wise, 9 and 7 don't have anything in common, but they can have a letter that is the GCF. So the GCF here is going to be x squared. What's that going to leave in the parentheses? 9x cubed plus 7. Boom. And I know that 7 is not a cubic number, so I know that's not going to be a difference, or a sum of cubes, because it's 2 terms. 9's not a cubic number, neither is 7. That's one of the rules of cubics. I'm trying not to give you those yet. We'll get to those in a little bit. Okay. Way on down the alphabet from here. All right. Let's do one more GCF problem. 6x squared y plus 8xy plus 12y. So a little bigger problem here. Got more terms. Got more letters in it. It's got 2 letters in it. So what do all of those have in common? 2, and everybody's got a y. So I'm going to pull out a 2y. What's that going to leave in the parentheses? Not 6, but 3x squared plus 4x plus 6. Boom. And we factored out the GCF there. That's all that one will do. There's nothing else that we can do on that. We'll kind of go through that in just a little bit about why that's not going to go any further. But all right. I'm going to go back up here and pull this one that I used up there, for example, F. I'm going to get x to the 3rd power plus 3x squared minus 5x minus 15. So is that in the right order? Yeah, definitely in the right order. Is there a greatest common factor across the whole problem? No. Almost. The 15 messed it up. It didn't have an x, so couldn't put that through there. And got a little bit in common with parts of it, but not everybody. Okay, so I've done the descending order part. I've done the GCF part. There wasn't one. The next thing is counting terms. So how many terms does this have? 4 terms. 4 terms because there's 4 pieces separated by pluses and minuses. The method for factoring 4 terms is grouping. So when you've got it in descending order like that, what you do is you group the first 2 together and then you group the last two together. And I usually do parentheses around the first two, and I underline the second two. And then you break it apart, and you say, okay, what's the GCF of the first two? Just those two. Disregard the negative 5x minus 15. X squared. So I'm going to factor out x squared, and then that's going to leave me x plus 3 in the parentheses there. Right? Okay. Then I go to the underlined set. What is the GCF of negative 5x and negative 15? Negative 5. What's that going to leave in the parentheses? X plus 3. Notice that those two parentheses match. If they don't match, something's wrong. Okay? Either it won't factor or I didn't get the GCF out. Okay? Those parentheses have to match. Now, the last step is to rewrite this in factored form. One of the factors is going to be the two that match, the two that are highlighted. So you got the x plus 3, and then you've got x squared minus 5. It doesn't matter what order you write those in. If you wrote the x squared minus 5 first and then the x plus 3, that's absolutely correct. I have a habit of writing the matching parentheses first. That's just my way of doing it. I've been doing it that way since I was in, I don't know what year it was I learned to factor, back in the 90s sometime. We'll say that. That maybe doesn't make me sound, it does make it. It's in the 1900s when I learned to factor. I wrote the parentheses one first and then the other one last. That's the way I've always done it. That's the way I'm always going to do it. Okay. Now, let's take another one and see if we can factor it. So example G, let's put 4x cubed plus 2x squared plus 10x plus 5. So all pluses in this one. So first check is descending order. It's in descending order? Good. We're ready to go. How many terms are there? Oh, what did I forget to do first? See if there's a GCF. So what messes it up? The 5 on the end. Everybody else was even, so I could have took a 2 out, but the 5 screwed it up. Okay? I'm the third of 3 boys. As my brother said, the last one screwed it up. I said I got away with everything, so I just was better at it than them. That's what it was. All right, so GCF of the first group. So first pair together, put in parentheses, underline the second pair. Make sure you underline that sign with it. So one of the most common issues that I have with students in factoring is they forget that sign is important in the middle there. So what's the GCF of the parentheses there? 2x squared. Good job. And that's going to leave what in parentheses? 2x plus 1. Now, on the underlined part, whatever sign is right there, that's going to be the sign of your GCF. Y'all did really good on the first one there on example F. Y'all brought the minus sign with you. Whatever sign is right there in the middle is going to be the sign in the middle. Okay, so what is the GCF of 10x and 5? Yeah, plus 5, and then that's going to leave us our 2x plus 1. Notice that those parentheses, they match again, so that means I did everything's working out wonderfully for me. So my final answer, factored form, is 2x plus 1, the matching parentheses, and then the 2x squared plus 5. And you factored it by grouping. Such a beautiful thing. Math, not magic. Fun times. Okay. This may feel a little bit more familiar because it hadn't been as long since you've done this as some of the other stuff we've done. You've had to do this more recently. All right, let's do another one. See if you can do this one. 10x cubed minus 6x squared plus 25x minus 15. See if you can get that one factored. It isn't too strenuous, I think. It's not too bad. Hopefully your matching parentheses is 5x minus 3, because 2x squared is the GCF of the first two, and then positive 5 is the GCF of the second pair. Leaves a 5x minus 3 in both of those parentheses. So we got the 5x minus 3. We got the 2x squared plus 5. If you like writing 2x squared plus 5 in the front and then a 5x minus 3 in the back, that's fine. I just do it this way because my brain will not do it a different way after 33 years of doing it. Okay. Questions about grouping? Okay. Now, let's do the bridging between grouping and X method. Okay. So, okay. Now, I realize that those two middle terms could be combined. Don't combine them. Okay. This is the kind of the in-between step between the X method and the grouping. Okay. So if I did grouping with this, I'd group those first two together and those last two together. And that would be X and X plus 6 plus 3 and then X plus 6. So I'd have X plus 6 and X plus 3. Now, where I like to tie this together is with trinomial that came from. So a trinomial's got 3 terms. I look at that, it's in descending order, it doesn't have a GCF. Always look for those two things first. Okay. This one doesn't have a GCF, it's already in order, we're good to go. The next step is on the count the terms, 3 terms says use the X method. And this is just my way of organizing my thoughts. When I was in high school and went through, I learned to factor by guess and check method, which is kind of what we're doing here, but we're doing an educated guess. Okay, guess and check method worked, but it took a while sometimes. This is more of an educated guess, so it cuts down how long it takes out of that. Now, the way I do it is with an X, and the way that it's set up, a trinomial is typically in this form. To make the X, you're going to multiply A times C, and then the bottom is going to be B. Okay? So, and then you're going to find 2 numbers that go on the sides that multiply to equal A times C and add to equal B. Those are what the 2 blanks on the side are going to be. So for this problem, when I do the X, what's in front of X squared? That's the A. What's in front of it? A 1. 1 times 18 is 18. and then 9 goes in the bottom. So I'm looking for two numbers that multiply to be 18 and add to be 9. So when I first think about 18, my first guess is going to be 9 times 2, which does multiply to be 18, but what's it add to be?
11.
So that's not the right pair. Mark them out. What's 3 times 6? 3 times 6 is 18. What's 3 plus 6? 9. That's the right pair. Now, if you had Miss Isbell, I know there's some of you that had her or had Miss Tull or Miss Bishop or any of those at McNary. I think they don't do an X. They do like a table like this, and they'll put the 18 over here and the 9 over there or something like that. That's how it's the same thing. I just use the X because it's easier to multiply. I don't do all T tables very well. Okay, now here's where that came from example, what was it? I replaced the 9x with the 6x and the 3x. And it doesn't matter what order you put those in there at. If you put the 3x in the front or the 6x in the front, it doesn't matter. Okay? As long as you replace the middle number with those two pieces from the side of your x. And then you group. And we already did that. That's x plus 6. That one's going to be plus 3. There's our matching parentheses. So we got x plus 6 and x plus 3. The shortcut is that if you have a 1 in front of x squared, notice how my factors have positive 3 and positive 6. That's a plus 3 and a plus 6. Whatever these numbers are on the side are going to be in my factors, as long as there's a 1 in front of x squared. If there's something else there, that doesn't work. Okay, you got to do the grouping stuff. So we can take a shortcut on this. It is worth it on this for the shortcut. So let's do a couple more problems like this. So let's take example J, and then next is K. X squared minus 7x plus 12. Okay. So make sure it's in the right order. Make sure there's not a GCF. So we are in the right order. X squared and 7x have x in common, but 12 doesn't have an x, so there's nothing else in common between that, so there's no GCF. So we're ready to do our x method because this is 3 terms. It's got 3 pieces. Multiply to be 12, add to be negative 7. Well, I'm going to try something. If I don't know, I'm going to try. So I'm going to go 6 times 2. That does multiply to be negative 12, but it adds to be positive 8. So that can't be it. What if I made negative 6 and negative 2? That still multiplies to be positive 12, doesn't it? But it gets closer. It's negative 8 this time. So better, but not right. Yeah, negative 4 and negative 3. That does multiply to be positive 12 because negative times negative is a positive. And then negative 4 plus negative 3 is going to add to be negative 7. That's the right pair. Because there's a 1 in front of x squared, this is my shortcut. I can go straight to the factors, x minus 4, x minus 3. Boom. I'm factored. If there's anything in front of the x squared, I can't do that. It has to be a 1 in front of the x squared for me to be able to do that. Okay? Be careful about that. Let's do another one. See if we can get it knocked out here. JKL. Let's do negative 32. Let's do 4x plus x squared. What's wrong with that? Not in the right order. Let's put it in the right order. X squared plus 4x minus 32. Now I'm in the right order. Look for GCF. X squared doesn't have anything in common with the other two. The 4x it did, but the 32 messed it up. The x squared messed up if you were doing the 4x and the 32. So no GCF. So I'm looking at how many terms. There's 3. So that's X method. What multiplies to be negative 32 and adds to be positive 4. So I got to think about things that multiply to be 32 to begin with. So this is where knowing your multiplication facts is a big thing. I always tell my students at high school, if they don't know their multiplication facts, there's an app for that. Download it. There's a multiplication app. If you just go to the app store and search multiplication, there's a little app that does that. And I've got it on my phone because when my boys were learning multiplication tables, I'd hand them my phone in the car. And we were going somewhere, they'd play that multiplication app to practice learning their multiplication tables. It's good practice. It doesn't take a couple of minutes a day, and you've got it memorized. 8 and negative 4, positive 8, negative 4. That does multiply to be negative 32. It does add to be positive 4. Because there's a 1 in front of my x squared, that lets me go to straight to my factors. What are my factors? Yeah, x plus 8, x minus 4. Boom. And you're done. Not too terrible. It's pretty easy. All right. So, when can we use that shortcut? 1 in front of the x squared. That's the only time we can use that shortcut. So don't try to use it when it's not a 1 in front of x squared. That's a very common mistake. Here's m. Let's get 4x squared minus 11x plus 6. Look for a GCF. Make sure you're in the right order. Do we have a GCF here? No. The 11 screws it up. Is it in the right order?
Yes.
What method should I use? The X method. So we're going to multiply A times C, so the front times the back, to get the top number. What's on top? 24. One of the biggest mistakes that I see is folks forget to multiply that 4 times that 6. They'll just put the 6 up there because that's what we did when there was a 1 in front of the x squared. It was that same number. But got to multiply 4 times 6 there. And then negative 11 goes in the bottom. So we're looking for two numbers that multiply to be 24 that add to be negative 11. Very good. Negative 8, negative 3. Can I go straight to my factors? No. Because there's a 4 in front of the x squared, this is where the grouping comes back. So I'm going to regroup it. 4x squared minus 8x minus 3x plus 6. Technically, it does not matter which one you put in the front, either the negative 8x or the negative 3x. I try to do it by what numbers are there. When I look at it, I know I'm going to put something with the 4, so the 8 and the 4, that's an easy GCF for me. And I know I'm going to put the 3 with the 6 because that's an easy GCF. Okay? It does not matter what your middle part, what order they're in. It will work out at the end. Your middle step will look weird compared to ours, but it still works. Okay? So we're going to group first two together. What's the GCF of the first group? 4x. What's that leave in the parentheses? X minus how much? 2. 2. Yeah, be careful there. And then what comes out of the second pair? Negative 3. Yeah, that minus sign. Remember that sign that's in the middle right there should be the sign of your GCF that you pull out. So that's going to give us a negative 3, and that'll leave us an x minus 2 in the parentheses. Because negative 3 times negative 2 is where the positive 6 is going to come from. Now we got it, the parentheses to match. That means we did things well. And so my factors are x minus 2, and 4x minus 3. That's not too bad. Y'all remember factoring in high school? I hope so. It's one of my favorite parts of algebra class was factoring. I don't know if you can tell, I'm a little bit excited. 6x squared minus 7x minus 5. See if you can do that one. What's on the top part of our x? Negative 30. Be careful on the sign there. Got to add to be negative 7. I'm just going to start trying things. That doesn't work. Negative 10 and 3. I know that the bigger number should be negative if it adds to be negative and multiplies to be negative. So I know they got to be opposite signs. So I'm going to do 6x squared, and then I'm going to do plus 3x, and then minus 10x. The reason I'm doing that is because I know the 6x squared and the 3x is an easy GCF. The 10 and the 5 is an easy GCF. It's not wrong if you did it the other way. It will still get you the same two factors at the end. But your middle step's just going to look different. Group. We've got a 2x plus 1 and a 3x minus 5. Not too bad. That's doable. X method and then grouping. The donut example. It's 2x squared plus 10x plus 25. X method, multiply to be 25, add to be 10. 5 and 5, right? Can I use my shortcut? Oh, yeah. I like that. That means things go faster. What's another way to write that? This is correct, but what's another way to write that? Yeah. X plus 5 quantity squared or x plus 5 squared, whichever way you want to say it. Both of those mean the same thing. Okay? So be able to recognize that. I'm not sure what multiple choice will look like on the final exam. I think on our Canvas stuff, it's like the first one, but if my memory is not 100% correct, I would not be surprised. All right, let's do another one of those. Let's say we had 4x squared Let's do minus 22x. That's right. Probably need a little help with the calculator there to get your 4 times 49, unless you're just really good at that. 160 plus 36, 196. That shouldn't be, change that from a 22, sorry. I wasn't thinking. Change that to an 18, minus 18. I think that's right. Or anything that multiplies to be 196 adds to be negative 18. God, not 18. 28. I can't do math. Sorry. The math ain't mathing tonight. It's Monday. I was off on fall break all week last week. I got a 28. I think it works now. I think. Should be negative 14 to negative 14. Does that add, that multiply be 196? Yeah. That definitely adds to be negative 28. So that's the right pair. Can I take my shortcut? No. So I'm going to go 4x squared. And the good news about this one is it doesn't matter. They're the same. So. Then group. So GCF of the first pair. 2x. That's going to leave us 2x minus 7. What's the GCF of the second pair? Negative 7. That's going to leave me 2x minus 7. And so my factors are 2x minus 7 and 2x minus 7, or 2x minus 7 quantity squared. What those are called are perfect square trinomials. Not that that's super important, but a perfect square trinomial just means it factors as the same factor twice. That's all that means. And the only way to know that they are is really just to factor them. You can recognize a pattern there if you'll notice. 4 is the square number and 49 is the square number. The square root of 4 is 2. The square root of 49 is 7. 7 times 2 is 14. And double it, that's the 28. That's the pattern that happens. But I just soon factor them. Just factor it and be done there. Okay. So we've done X method. That's a lot of stuff there. Okay. So far we've done grouping. We've done X method, which involves some grouping. Now we've got to look at the two-termed monsters that lurk into the world here. So let's get into some of those. So example Q, let's do x squared minus 4. So first thing I look for is a GCF. I make sure it's in the right order. So x squared minus 4, that's definitely in the right order. That does not have a GCF. Then I count the terms. There are two terms with a minus sign in the middle. So that's either got to be a difference of squares or a difference of cubes. How do I recognize that this is a difference of squares? Yeah, I got a x squared there. And then I know 4 is also a square number, right? It's 2 squared. So that's what I'm going to do. I'm going to rewrite this as two things squared. What squared gets me x squared? X. What squared gets me 4? Yeah, a 2. Yeah, so I've that minus sign just hanging in the middle there. So that's where your negative's coming from. Now, here's the shortcut on differences of squares. The factors Both of them will have an x in the front and a 2 in the back. One's a plus, one's a minus. Boom. Remember in the first section in R3 when we were multiplying those together, and I said, hey, that's a difference of squares because the factors are the same. One's a plus and one's a minus. That's what a difference of squares factor's like. Okay. So rewriting it as a difference of squares, let's say we had 16x squared minus 25. So GCF 16 and 25 don't really have anything in common, so nothing I can do there. It's in the right order already, so we're good to go there. And then it's got a minus sign in the middle. It's got an x squared in it, so that's what tells me x is it's a difference of squares. So difference of squares there. I want to rewrite it as something squared minus something squared. So what's going to give me 16x squared? 4x. What's going to give me 25? 5 squared. Okay. So then I get to take my shortcut. 4x in the front, 5 in the back. 4x in the front, 5 in the back. One's a plus, one's a minus. If you like putting the minus in the first one and the plus in the second one, go for it. I don't care. It's the same.
So if we leave it as the 4x squared minus 5 squared, it's wrong?
That's not factored.
Okay.
You want to end up with the factors like that with the two little parentheses things going on. This is kind of the thinking you want to use to recognize and do that factoring with it. Let's do this one. 49x squared minus 1. I know 1 goes into both of those, but that's not going to help us. So I see a squared thing happening there. What squared gets me 49x squared? 7x. What squared gets me 1? 1. A lot of folks forget that 1's a square number as well. Just because it's so simple, we just forget it. It's kind of like our ones times tables, or sometimes the ones we forget exist because they were so easy, we just don't think about it. So we got 7x plus 1. Excuse me, sorry. I know that was super loud. I apologize. My wife loves that about my sneezes. They're so loud. So 7x plus 1, 7x minus 1. You factor the difference of squares. Now, where it gets a little bit more technical, a little bit more difficult, maybe, would when you have something like 25x to the 4th minus 144, where it doesn't have an x squared on it. And so it makes it kind of more in disguise as far as the difference of squares part. So this is still a difference of squares. The reason I know it's squares is because of the numbers. I've got a 25, which I know is 5 squared, and I got 144, which I know is what? 12 squared. So that helps me kind of recognize that this is a difference of squares. So when I go to rewrite that, I got to think a little bit on that x to the 4th. I know it's a 5, but what squared is going to give me x to the 4th? X to the second. Yeah, x squared is x to the 4th. And then on the 144, I got the 12 in there. So now I've got my pieces for my factors. 5x squared in the front, 1's a plus 12. 5x squared in the front, 1's a minus 12. using those to kind of help us along the way there. That little shortcut for differences of squares. Sometimes they'll disguise it in there. Know your square numbers a little bit, at least the smaller ones. I'm not saying you got to know them to 20 times 20 or anything like that, but up to 12 times 12, really know those well and be able to recognize them. That'll help you with the differences of squares. All right, now for the new thing, the sum and difference of cubes. You may or may not have factored this in Algebra 2 when you were in high school. I don't know. If you did, great. If you didn't, we're going to learn it today. It's not that, it's a pattern type thing. So let's do the sum of cubes. The sum of cubes is where you have something cubed plus something cubed. The pattern for the factoring of a sum of cubes, you're going to have a short factor, you're going to have a long factor. The short factor is going to be the same as this, just take the cubes off. So we're going to have a plus b. Okay, that's going to be the first factor on a sum of cubes, is a plus b. The second factor is going to be a squared minus ab plus b squared. So whatever number was inside of these little parentheses right here, or letter, or whatever, you're going to square it and put it right there. Whatever number was in the inside here, you're going to square it and put it on the end. The middle piece, you're just going to multiply these two numbers together, whatever's in there. And then it's going to be a minus sign every time on the sum of cubes. The short factor has the same sign. That's always what happens. The short factor always has the same sign. That's the key. So on the difference of cubes, once we learn this pattern, the only thing that changes are the signs. The difference of cubes, you got something cubed minus something cubed. You're going to have a short factor and a long factor. The short factor is going to be a minus b. Notice that that's almost the same as that, just a minus sign in the middle. The long factor is going to be a squared plus ab. Always going to be plus on that b squared. The reason it's always plus there is because no matter what you do, if you square it, it's going to be positive, right? Whatever that number is, if you square it, if it's a -3 squared is going to be +9. That's why that's always going to be a plus. That is as far as a sum or a difference of cubes will factor. Okay? So memorizing these patterns is really what you got to do. Okay? So let's take a problem that's got some numbers and an x in it and work our way through that. I have no idea what letter I'm on. I've added extra examples in when I felt like we needed it. TU. We may get through the whole alphabet. I don't know. Let's do x squared plus, or not x squared, x cubed, sorry, plus 27. Okay, we're going to factor that. Okay, so same instructions that we've been doing the whole night, factoring that. So I'm going to rewrite it as x cubed, and then what cubed is 27? Can't be real big because cubes, yeah, 3 times 3 is 9 times another 3 is 27. So it's 3 cubed. So x is my a and 3 is my b. This is a sum of cubes. So it's going to look like that one up there. It'll look like the top one. But where their a's are, it's going to be an x. Where the b's are, it's going to be 3's. Okay? So we're going to multiply that and we're going to work that out. So the factored form, I'm going to have x plus 3, x squared minus x times 3 plus 3 squared. So I'm just rewriting it exactly like the pattern said. I did not change any of it other than the a and the b, changed to x and 3. Then I'm going to work out the pieces that can be worked out. The only pieces that can be worked out are the middle piece and the 3 squared. 3 times x is 3x. So my final factored form is going to be x squared minus 3x plus 9.
If we skip the part before it's from.
Yes. Yeah, if you've got that pattern memorized, and if you've done a few of these, you'll start skipping that step because it's just multiplying. It's not really that much work. So that skipping that step can be a good thing. Okay? Let's do x to the third minus 8. So it's got an x cubed in it, so that makes me think, okay, it's got 2 terms. It's got an x to the third power. It's a minus sign in the middle, so that's going to be a difference of cubes, hopefully. What goes in the first parenthesis there? What goes in the second? 2. So a is x, b is 2. So my factors, the short factor, long factor. I always just set it up that way. What's the short factor? Very good. What's the long factor? X squared plus 2x plus 2 squared, which is 4. That trinomial hanging on the end, that long factor, it will never factor any further. When you factor a sum or difference of cubes, that's as far as it goes. Let's step it up a notch or two here. W. Let's say we had 27x cubed plus 64. So when I look at that one, I see a plus sign with two terms with an x cubed. So I think, man, that's got to be, maybe it's a sum of cubes. I look at the numbers to see if there's a GCF, because if I could make them smaller, it'd be a lot easier. But 27 is divisible by 9. 64 is not divisible by 9. 27 is divisible by 3. 3 doesn't go into 64, so no GCF. So I'm ready to set up my sum of cubes. 3x and 4. Very good. Let's see if we can factor that. Long factor, short factor. What's the short factor? Yeah, that's the easy one. Everybody ought to be able to get the short one right. Just take the cubes off. Now the long factor, it's a little tougher on this one because you got that 3x in the first spot. So we're really squaring 3x. And we're really multiplying 3x times 4 in the middle. And then we're squaring 4 on the end. So maybe on this one, writing that extra step in there is helpful because it's a bigger number. It's bigger things. Because I'm squaring that 3x. It isn't just x squared in the front. It's 3x squared. So that turns into 3x plus 4. And then what's the long factor?
3x squared.
What happens when you square 3x? Yeah, the 3 becomes a 9 because it's 3x times 3x. So that's 9x squared minus 12x plus 16. That's where that extra step in there is muy importante. That step right there is what'll get a lot of us, is that squaring that first term. Or anything that's got a coefficient on it. All right, let's get one more, and we'll move on. 125 x to the third minus 1. Yeah. Huh? Yeah, x comes before y, doesn't it? I'm a math teacher, not an English teacher. You don't need the alphabet, pass. We're on x. Sorry. All right. What would this one be?
5x and
Yeah, 5x and a 1. So it's a difference of cubes with a 5x and a 1. So we've got short factor and a long factor. Short factor is the easy one. What's the long factor?
5x squared.
All right, so I'm going to
5x squared.
got the 5x squared. I have a plus 5x times 1. Then I have a plus 1 squared. I'm just going to clean that up a little bit. What's my long factor turn into?
25x squared plus 5x plus 1.
25x squared plus 5x plus 1. And there you have factored a difference of cubes. We're this close to the end of the alphabet. We might as well do a couple more. Let's do a couple of completely factors. Okay? So, example Y. Let's look at this one. Let's say we had 10x squared minus 80x plus 160. And the instructions say factor completely. So that means that kind of implies that there's going to be more to do than just one thing. So what's the first thing that we can do on this one? Pull the 10 out, GCF. That's good. So 10 comes out. That's going to leave me x squared minus 8x plus 16. And then I can factor that x squared minus 8x plus 16 using the x method. Or I can attempt to factor it using the x method. That doesn't necessarily mean it will factor, but I'm going to attempt to at least. So is there anything that multiplies to be positive 16 and adds to be negative 8? Ooh, negative 4 and negative 4. Ooh, that's good. Can I use my shortcut? Yeah, because I pulled that 10 out of the way. So all that's left here, so it's like that 10 is just not there for right now. It's just hanging out, watching what's happening. So this x squared has a 1 in front of it. So I can use my shortcut on that. And that's going to leave me x minus 4 and another x minus 4. And I've still got the 10 that I pulled out at the beginning. How else could I write that?
10 and then x minus 4 squared.
Yeah, both of those are true. Not too bad. GCF first, and then we had to factor it another way. That happens. Let's do one more in this section. We'll take a little break and then come back and do a couple of short sections. So finally got through the whole alphabet. I always kind of feel like I've done something when I get there. So example Z, let's do x to the third minus 5x squared minus 4x plus 20. So it's in the right order. That's good news. Is there a GCF?
No.
No. So what do I do? Group. Because there's how many terms? 4 terms is grouping. So that's why we're grouping. First 2 together, second 2 together. What's the GCF of the first 2? X squared. 1 and an x squared. So then that's going to leave me x minus 5. What do I pull out of the second pair? a negative 4. And that's going to leave me x minus 5 in that one. Come on. There we go. And so my factors are going to be x minus 5 and then x squared minus 4. Will one of those factor further? Which one? Why? Difference of cube?
Difference of squares.
Very good, Brooklyn. The difference of squares, because x squared is a square and 4 is 2 squared. So that's a difference of squares that I can factor as x squared minus 2 squared. So that's going to be x minus 5, and then my factors are going to be x plus 2 and x minus 2. And that is factored completely with that polynomial. So always when you see in the instructions factor completely, kind of think, there's probably more than one step on this kind of stuff. Always look to see if you can factor something further, because the more you can break it apart, the easier it gets as far as when it goes to the solving part. Okay. All right. Let's take a short break. I know we're all getting tired of sitting for a second.